Hello grade 9 learners, have a nice day. Welcome back to my channel. If you are new to this channel, please don't forget to subscribe and click the notification bell. Thank you. By the way, for today's video, I'll be discussing to you about solving quadratic inequalities. This is grade 9 lesson for week 6 in the first quarter. Now let's begin with steps in solving quadratic inequality. The first step is write the quadratic inequality into standard form. And I have discussed with you in my previous video about the standard form of quadratic inequality. Second, change the inequality sign to an equal sign and equate to 0. Third, solve the quadratic equation using any of the 4 methods in solving quadratic equations. And in case you have forgotten about the 4 methods of solving quadratic equations, just go over my videos. Fourth, plot the roots on a number line by drawing an open circle or hollow circle if the inequality involves less than or greater than, or closed circle or solid circle if the inequality involves greater than or equal to or less than or equal to. This will divide the number line in different regions. Fifth, select one point on each region and substitute them into original inequality to test which among the regions contain values that would satisfy the original inequality. And last, write the solution in interval notation. Now let's have the first example. Find the solution set of x squared plus 7x plus 12 is greater than 0 in graph. Okay, first, we have to copy the inequality since inequality is already in the standard form. Next, the inequality symbol that is greater than will be replaced by equal sign. So we have now x squared plus 7x plus 12 is equal to 0. We have now quadratic equation in standard form. So we are going to solve this by factoring. Factors of x squared are x and x. Factors of 12 that will give a sum of 7 are 3 and 4. Next, equate its factor with 0. So we have x plus 3 is equal to 0. And the other one is x plus 4 is equal to 0. Solve for x. So 3 will be transposed to the right side and 3 became negative 3 while 4 became negative 4. So we have now the two roots, negative 3 and negative 4. After that, we are going to plot the roots in a number line. Okay, we have here a number line. We are going to locate negative 3 and negative 4. We are going to draw an open circle or a hollow circle since we are dealing here with greater than symbol. Okay, so we have negative 4 and open circle also at negative 3. Next, we have to determine the 3 regions. So we have now the 3 regions. We have this. So this is the first region. I will label it A. And this part here will be the second region, and this part here will be the third region. For the first region, the interval is x is less than negative 4 but greater than negative infinity. So we are going to select a point in every region that we are going to substitute to the original inequality to test which among the regions contains the values that satisfy the inequality. So for this region, we have to choose either negative 5, negative 6, or so on, but this time we'll just choose negative 6. Okay, for this region, in between negative 4 and negative 3, so we'll just choose negative 3.5, or that is negative 3 and 1/2. Okay, in between negative 4 and negative 3. And for this region here, we have the interval of x less than positive infinity but greater than negative 3, we cannot choose 0. So we have already negative 6, negative 3 and 1/2, as well as 0. Then we are going to test the chosen point for each interval. So for the interval x less than negative 4 but greater than negative infinity, we had chosen negative 6 as our point. So copy the original inequality. So we have x squared plus 7x plus 12 is greater than 0. Next, substitute x by negative 6. So quantity of negative 6 squared, that is equal to 36. 7 times negative 6, that is equal to negative 42. Bring down 12 is greater than 0. Simplify further. 36 plus 12 is 48 minus 42, that is positive 6. And 6 is greater than 0. This is a true inequality. So it means that this is part of the solution. For the second interval, where x is less than negative 3 but greater than negative 4, we had chosen the point negative 3 and 1/2, or that is negative 3.5. But this time I use it as fraction form. So we have to change first negative 3 and 1/2 to improper fraction. So 2 times 3 is 6 plus 1, so we have 7. Then copy the denominator part 2, so we have 7 over 2. Since this is negative, so we have negative 7 over 2. Copy the original inequality. Substitute x by negative 7 over 2. So quantity of negative 7 over 2 squared, that is equal to 49 over 4. So negative 7 times negative 7, that is 49, and 2 times 2 is 4. Then 7 times negative 7 is negative 49. 1 times 2, 7 has a denominator of 1, so that is equal to 2. Bring down 12, greater than 0. Simplify further. We are going to simplify fraction and whole number. So we have to find the least common denominator. And the least common denominator is 4. So 4 divided by 4 is 1. 1 times 49 is 49. Next, 4 divided by 2 is 2. Minus times 49, we have 98. Then 4 divided by 1, the denominator of 12, times 12, we have 48. Greater than 0. Simplify further the numerator part. So 49 plus 48, that is 97, minus 98, that is negative 1. Copy the denominator, which is 4, greater than 0. So negative 1/4 greater than 0 is a false inequality. So therefore, this is not part of the solution. For the third interval, where x is less than positive infinity but greater than negative 3, we chose 0. Copy the original inequality. Substitute x by 0. So we have 0 squared is 0. 7 times 0 is 0. Bring down 12. Greater than 0. So 0 plus 0 plus 12. So we have 12 is greater than 0. And this is a true inequality. Therefore, for this interval, this is part of the solution. We have also to test the points x is equal to negative 4 and x is equal to negative 3. So for x that is equal to negative 4, again, copy the original inequality. Substitute x by negative 4. So quantity of negative 4 squared, that is equal to 16. 7 times negative 4 is negative 28. Bring down 12, greater than 0. 16 plus 12 is 28, minus 28, that is equal to 0. 0 is greater than 0 is also a false inequality. So it means this is not part of the solution. And last, we have to test x that is equal to negative 3. Copy the original inequality. Substitute x by negative 3. So quantity of negative 3 squared, that is 9. 7 times negative 3 is negative 21. Bring down 12, greater than 0. So 9 plus 12 is 21 minus 21, that is equal to 0. So 0 is greater than 0 is a false inequality. So meaning this is also not a part of the solution. Okay, for our graph, we have here an open circle or a hollow circle at -3 and -4. And we have here the shaded region going to the positive infinity and going to the negative infinity. So it means that the part with red is the solution. And for the solution set of the inequality, that is the set of all x such that x is less than to -4, this part here, or x is greater than -3, this part here going to positive infinity. In interval notation, it is written as -infinity, then -4, meaning -4 is excluded. That is why we use the parentheses. Union, -3 up to positive infinity. Now let's have the second example. Find the solution set of x squared plus 2x minus 8 is greater than or equal to 0 in graph. So same with the first example, we have to copy the inequality since the inequality is already in the standard form. Next, replace the inequality symbol by equal sign. Now we have quadratic equation in standard form and we are going to solve for x. So we're gonna use factoring. Factors of x squared are x and x. Factors of -8 that will give a sum of 2 are 4 and -2. Equate it with 0, and now its factor will be equated with 0 and solve for x. So 4 will be transposed to the right side and it became -4, and -2 transposed to the right side and it became +2. So the roots are -4 and +2. Next, we have to plot the roots on the number line. So this time, we are going to use solid circle or closed circle since we are dealing with greater than or equal to symbol. So at -4, we have here a solid circle, and at +2, we have also a solid circle. Now, the number line is being divided into 3 regions. So the first region is this part here. I will label it A, and the second region, this part here at the middle, this is the second region, and for the third region, this part here, so this is the third region. And in every region, we're going to choose a point that we're going to test to the original inequality. So for this region where the interval is x is less than or equal to -4 but greater than or equal to negative infinity, we have to choose -5. And for this region here where x is less than or equal to 2 but greater than or equal to -4, we will choose 0. You can choose any point actually. And for the third region, where x is less than or equal to positive infinity but greater than or equal to 2, we have to choose 4. Okay, these points, we have to test this in the original inequality, which is x squared plus 2x minus 8 is greater than or equal to 0. Now, we have to test the chosen point for each interval. For x that is equal to -5, copy the original inequality, substitute x by -5, so we have quantity of -5 squared, meaning -5 times -5, that is 25. 2 times -5 is -10. Then bring down -8 is greater than or equal to 0. So we have 7 is greater than or equal to 0. So meaning to say, this is true inequality. This is part of the solution. Next, for the second interval, where x is less than or equal to 2 but greater than or equal to -4, we had selected 0. Copy the original inequality. Substitute x by 0. So 0 squared is 0. 2 times 0 is 0. Minus 8 is greater than or equal to 0. 0 plus 0 minus 8 is greater than or equal to 0. So of course, 0 minus 8, that is equal to -8, and it is greater than or equal to 0, which is a false inequality. So it means for this interval, this is not part of the solution. For the third interval, where x is equal to 4, first copy the original inequality, substitute x by 4. So we have 4 squared, 4 times 4 is 16, 2 times 4 is 8, minus 8. So bring down -8 is greater than or equal to 0. Then simplify. 16 plus 8 minus 8. The answer is 16 is greater than or equal to 0. This is a true inequality. So it means for this interval, this is part of the solution. We have also to test the point where x is equal to -4 and +2. For x that is equal to -4, same, copy the original inequality. Substitute x by -4. So we have quantity of -4 squared, that is equal to 16. 2 times -4 is -8. Bring down -8 is greater than or equal to 0. 16 plus -8 minus 8, that is equal to 0. So 0 is greater than or equal to 0, which is also a true inequality. So it means that this is also a part of the solution. Last, for x is equal to 2, copy the original inequality, substitute x by 2. So we have 2 squared, that is equal to 4. 2 times 2 is 4. Bring down -8 is greater than or equal to 0. So 4 plus 4 minus 8 is 0. Greater than or equal to 0, which is also a true inequality. Therefore, this is also part of the solution. So for a graph, we have here solid circle at 2 because it's part also of the solution. And since for this interval, we have a true inequality, so that is why we have a shaded ray going to this point. And this one here at -4 is also part of the solution. That's why we have here a solid circle. And going to this interval, this is also part of the solution. So the solution set of the inequality is here, x is less than or equal to -4. And this part here, x is greater than or equal to +2. For the interval notation, we have -infinity, this part here, up to -4. So we use the bracket sign because -4 is part. Union 2, bracket sign again because 2 is part of the solution, up to +infinity. So these are the solution set. Now let's have the third example. Find the solution set of 2x squared plus 5x is less than or equal to 12 in graph. If you have observed, the given inequality is not yet in standard form, so we're going to transform this one first into standard form. So we have to transpose 12 to the left side of the inequality, and the resulting inequality now is 2x squared plus 5x minus 12 is less than or equal to 0. Next, we are going to replace less than or equal to sign by equal sign. So we have now an equation. 2x squared plus 5x minus 12 is equal to 0. Now we're going to solve for x. This time we are going to use factoring. So factors of 2x squared are 2x and x. Factors of negative 12 are negative 3 and 4. But let's try to check first if we have a sum of 5x. So we're gonna multiply negative 3 times x. So the answer is negative 3x. And we have also to multiply 2x and 4. So 2x times 4 is 8x. Next, we have to add. So negative 3x plus 8x, that is equal to 5x. And 5x is the middle term. So therefore, we are correct with the pair of our factors. So now we're going to equate its factor with 0. So we have 2x minus 3 is equal to 0, and the other one is x plus 4 is equal to 0. So for x, so negative 3 will be transposed to the right side, and it became positive 3. And we're going to divide both sides of the equation by 2. So 2x divided by 2, that is equal to x. And 3 divided by 2 is, we have 3 halves. So this is now the first root. For the second root, we have x plus 4. And 4 will be transposed to the right side, and it became negative 4. So we have now the second value of our root. Now we are going to plot the roots on a number line. So this time we are going to make use of a solid circle because we have here less than or equal to. So we have to locate negative 4 and 3 halves. So 3 halves, this is actually equal to 1 and 1 half. So solid circle at 1 and 1 half we have here, and also solid circle at negative 4. So now the number line is being divided into 3 regions. We have here the first region. This is the first region going there to the negative infinity, and here the middle part is the second region. I'll label this as B, and going there is the third region. We are going to choose a point in every region, so you can choose any point, but for this time, for this interval, for the first region where x is less than or equal to negative 4 but greater than or equal to negative infinity, we have to choose negative 5. And for the second region, you can choose any point, but this time we will choose 0. This is for the interval where x is less than or equal to 3 halves but greater than or equal to negative 4. And for the third region of interval is x is less than or equal to positive infinity but greater than or equal to 3 halves. We will choose 2. Now we are going to test the chosen point for each interval. Okay, for this interval, we have x that is equal to negative 5. Copy the original inequality. Substitute x by negative 5. So 2 times quantity of negative 5 square. So bring down 2. Negative 5 square is 25. 5 times negative 5 is negative 25. Less than or equal to 12. 2 times 25 is 50. Bring down negative 25. Less than or equal to 12. 50 minus 25 is 25. Less than or equal to 12. This is false inequality. Therefore, this interval here is not part of the solution. For the second interval, we had chosen 0. So copy the original inequality, substitute x by 0. So 2 times 0 squared, of course, 0 squared is 0 times 2, that is equal to 0. 5 times 0 is 0, less than or equal to 12. So 0 plus 0 is 0, less than or equal to 12. This is true inequality. Therefore, this interval here is part of the solution. For x that is equal to 2, For the third interval, copy the original inequality, substitute x by 2, so we have 2 times 2 squared, so bring down 2, 2 squared, 2 times 2 is 4, 5 times 2 is 10, less than or equal to 12. 2 times 4 is 8, bring down 10, less than or equal to 12. 8 plus 10, that is equal to 18. 18 is less than or equal to 12. This is also false inequality, meaning this interval is not also a part of the solution. To test the point where x is equal to negative 4, copy the original inequality, substitute x by negative 4. So 2 times negative 4 squared, bring down 2, negative 4 squared, that is negative 4 times negative 4 is 16, 5 times negative 4 is negative 20, less than or equal to 12. 2 times 16 is 32, minus 20, less than or equal to 12. 32 minus 20 is 12, less than or equal to 12. This is a true inequality. It means x is equal to negative 4 is part of the solution. For x equals 3 halves, copy the original inequality, substitute x by 3 halves. So 2 times 3 halves square plus 5 times 3 halves less than or equal to 12. So bring down 2. 3 times 3 is 9 and 2 times 2 is 4. 5 times 3 is 15. Bring down 2. Less than or equal to 12. Now multiply. 2 times 9 over 4. We can factor out 4 as 2 times 2. So we can divide the common factors, which is 2. So that's why we have here 9 over 2. And 9 over 2 plus 15 over 2, the same denominator, copy the denominator 2 and add the numerator. So 9 plus 15, that is equal to 24. And 24 divided by 2 is equal to 12. So 12 is less than or equal to 12. And this is a true inequality. So it means at x that is equal to 3 halves, this is also part of the solution. Okay, for our graph, we have here solid circle at negative 4, part of the solution, as well as at 1.5 or 3 halves. And for the second interval, which is through, we have here where x is less than or equal to 3 halves, but greater than or equal to negative 4. So this part here. So the one shaded with red is part of the solution. So therefore, the solution set of the inequality is x less than or equal to 3 halves, but greater than or equal to negative 4. So for the interval notation, we have to start with negative 4. And we gonna make use of the bracket. So negative 4 meaning to say its part. We have just to copy the first and the last. So negative 4. Then parentheses. And then here we have 1.5, or that is 3 halves. So we are also using the bracket because 3 halves is part of the solution. Thank you so much for watching, guys, and if you learned, kindly comment, and if you have questions regarding the video, don't forget to comment in the comment box. Kindly share to other students for them to learn or master the lesson. Don't forget to subscribe to be updated for more math lesson videos and turn on the bell for notifications. Before I end, let me share to you one of the verses from the Bible. When pride cometh, then cometh shame, but with the lowly is wisdom. Proverbs 11 verse 2. That's all for today, and God bless you all.